Well, it's hard to believe this will probably be one of the last podcasts I do for a while for you guys. It's really been fun being with you in class. So I thought I would wrap up the activities that you did this last week with Valley when I was gone. So one of the activities was to build the longest pendulum that you can and then figure out what its frequency was. Then the challenge was to build another pendulum that had twice the frequency of the big long one. And I think what you discovered was it wasn't just half of the length. It was a lot less than that. And as you play around with those numbers, you might actually be able to figure out mathematically what the difference was between those lengths. So let's review a little bit what we've talked about before. This graph here on the left-hand side has frequency in centimeters, and it has the frequency in cycles per minute. Then the column with the middle graph, our table right there, has added another column on the right hand side that's called frequency, but it's measured in hertz, and hertz is in cycles per second. So to get the cycles per second, what they did was you take the cycles per minute and divide it by 60. You can see the math down below those two tables, and you come up with 1.28. Well, you could do the same for the rest of the frequencies on those tables, like 79 divided by 60, 82 divided by 60. So when you do that and you graph everything out, you can see what the graph looks like. It's real similar to that first graph that we built in class. So you've got a short string length, you've got a really high frequency. You've got a long string length, you've got a really slow frequency. Well, one of the things that scientists like to do is what we call play the math game. And you know, in mathematics, there's lots of things we can do to numbers. We can add, subtract, multiply, divide. We can find the square root of numbers. We can square them. We can, cube them. There's lots of different things we can do. So as people have time on their hands and they're kind of math geeks, what they start to do is play with numbers. So we just saw a second ago that table that had cycles per minute and then cycles per second. Well, one of the things you can do in mathematics is turn those numbers around. So in this case, the period is listed as seconds per cycle. So how many seconds or parts of a second does it take to make a cycle? And you can see from that table that a length of 2 centimeters takes 0.313 seconds to complete a cycle, whereas a length of 15 centimeters takes 7/8 of a second to make a cycle. Well, again, one of the things we can do with math is start to play with those numbers. So what some folks did one day was take that period column and they squared it. So they took 0.313 and squared it, and they got 0.098. And then they took the next frequency and squared it. So now you have a whole nother table of a column of figures that match up with the lengths. And what's really cool is when you graph those, what you find out is you end up with a straight line. Now, mathematicians really like straight lines when it comes to graphing because that indicates a linear relationship. So we can begin to describe the length and the frequency of a pendulum as a linear relationship when we play the math game. So when we square the period, which is the seconds per cycle, we end up with a linear relationship. Now this is just really scratching the surface in terms of some of the mathematics that you guys can play with pendulums, but it is pretty cool and pretty interesting. So I hope that kind of explains what you were doing and why you were doing what you were doing in class last week. What you could do is go back and take a look at the figures and the numbers that you got for the longest pendulum, for the next one that had twice the frequency of the first one, and the third one that had twice the frequency of the second one. Look at those and see if that pattern still doesn't play out with the figures that you came up with, and it should. Okay, so that was the first activity. Now the second one you did was you built a double pendulum system using a string and then a couple of pendulums. And if you started one of those pendulums swinging and just let it go for a while, I think what you should have noticed was that, let's say we start with the ball on the right hand side. We pull it back, let it go. The one on the left is pretty much sitting there still. It might be swinging a little bit just due to the fact that it's on a string. But eventually the energy from the first pendulum swinging will be transferred to this second one, the pendulum on the left. The one on the right will stop momentarily. The one on the left will continue to go, and then it will begin to transfer the energy back to the first pendulum. And it's really cool because that transfer of energy moves back and forth as that pendulum continues through its different cycles. It's a really good example of energy transfer. It has to do with frequencies as well, and it's really, again, scratching the surface of some of the things that happen with pendulums. So I hope you guys enjoyed those activities. Again, it was really fun working with you, and I hope you have a great Christmas, and I'm sure I'll see most of you around. Thanks.